in this exercise, we are going to modify the shooting game. Previously, we used the view to implement the user interface for the shooting game. So we extended the view to implement a custom view. Now in this version, we are going to extend a surface view rather than a view. Now what does a surface view bring to the table? Now surface view allows you to update the canvas in a background thread at your own leisure, and when you have completed updating the canvas, then you can post the canvas to the UI. So this enables you to implement a lot more complicated graphics updates to the canvas, because the updates are going to be taking place behind the scenes, and then you would be able to update the user interface. So as you see, the game looks exactly the same, except that now the canvas is handled using a surface view rather than a view. After the end of this exercise, I'm going to explain the difference between surface view and a view, and the way you implement the surface view in an application in Android. In particular, when you are using surface view, you need to implement, first and foremost, 3 different callback methods that will handle, like called on surface created, on surface changed, and on surface destroyed. In addition, you need to create a background thread. So that is where the action comes in for this particular exercise. As usual, once you download the zip file that we provide for you to get you started on this exercise, unzip the file and then import it into Android Studio. Now once you do that, you will notice that most of the code will remain more or less the same as before. The major updates would be in the drawView.java class. So let's focus on the drawView.java class and understand how we have updated this class to use the surface view rather than the view. So once you import the project into Android Studio, open drawView.java file and then have a look at the code, and I will explain the modifications here, and then we will go in and look at what needs to be updated in this drawView.java file. So once you open the file, the first thing you will notice is that now the drawView class is extending surface view rather than view as before. And in addition, when you extend surface view, as I mentioned, you need to implement some callback methods. So that's why we have this implements surface holder callback methods. There are 3 callback methods that need to be implemented, which I will show you in the code later on. Now, once you go into the code, you will also notice that we now have a variable called the drawView thread that I have declared here. This variable is going to hold the reference to the thread that we need to create, the background thread on which the updates are going to take place. If you are familiar with Java threads, you understand how threading works. If you're not familiar with Java threads, it's okay. You need to understand just the parts that we have in this file to get you started. Now, when you look at this example, you realize that you might have a lot of updates to the canvas to be done. Previously, we were doing the updates inside the onDraw method. Now, the problem with that is that the onDraw method is going to be executed on the main thread of your application. And this might end up slowing down your application in case you have a lot of updates to be done to the canvas. Now, it is suggested that if you have complex operations to be done to the canvas, then it is better to shift that work to a background thread. So a background thread executes off the main UI thread. So if you look at it from the programming perspective, if you're familiar with threads, the main UI thread is a sequence of execution that is going on. When you have a background thread, it is going to do its work separate from the main sequence of execution. So on your CPU, your background thread is going to execute separately from your main UI thread. So there will be no interference with the main UI thread as such. This enables you to do the work in the background, and when you have completed updating the canvas, then you can come back and post it back to the user interface and then update the UI at that point. So this is essentially what we're going to make use of in the Surface View here. Now, in addition, within the draw view constructor, you would notice that I am doing a get holder add callback this, essentially to inform the Android framework that this class is going to implement the callback methods for the Surface View. Okay. Now, getting down into the code, you will notice that I have three methods that I have implemented here: surface changed, surface created, and surface destroyed. Now, in the surface changed method, I am not doing anything interesting for this example, so we're going to leave it blank. In the surface created method, now when the surface gets created, essentially meaning that the UI is now up and running, and then there is a portion of the UI that has been allocated to this custom view that we implemented, the draw view, and that has to be updated. Now this should be done in a background thread. So when the surface created method is called, the Android framework is coming back to your code and informing you that the surface is ready, and so you need to start working on updating the canvas at this point. So in the surface created method, we are going to start the background thread, and the way you start a background thread is to create a new thread, and later on I will show you the code for this draw view thread down below. That is where the major focus of our update is going to be. So we create the draw view thread, and then this draw view thread takes a parameter called the surface holder, which we are going to get hold of when we are executing the updates to the canvas. So this surface holder is going to come in as a parameter here. This surface holder enables you to get access to the canvas so that you can start updating the canvas. So once you have created the thread, you're going to start the thread in the surface created method here. Now, in the surface destroyed method, this method will be called when your UI is destroyed. So when your activity quits, at that point, the surface destroyed method is called. At this point, you need to shut down your background thread because it is no longer needed. So that's the code that we have here for shutting down the background thread. Now, the updates to the canvas is exactly the same as we did earlier. We had this method called the draw game board, and so that method will still be used for updating the canvas, except that now the canvas updates are going to happen in a background thread. Now, where exactly is the code for this background thread? For that, we will walk down to this method that we have, this inner class that we have implemented here called the draw view thread. This draw view thread class is extending the thread class. When you extend the thread class inside here, you will have to implement a method called the run method. So when the thread starts executing, the code inside the run method is going to be executed. So inside this run method, we are going to do the updates to the canvas. Okay, so inside this draw view thread class, you see that we have a constructor. In the constructor, I am getting hold of the surface holder, and that allows me to get access to the canvas. So I'm going to store a reference to the surface holder which came in as the parameter here, and also I will set the name of the thread in case I need to use it elsewhere. Now, in addition, I am implementing another method called setRunning. This method will be called to enable the thread to be running. So this method sets a Boolean variable to indicate that the thread is running. So if, for example, you pause your game, so for example, if you hit the home key and then move back to the launcher screen, at that point your activity will be paused. So when your activity is paused, you're going to pause your background thread also, and then when your activity resumes, you're going to come back and resume the background thread. These two parts are implemented in the activity class. So let me switch quickly to the activity class, which is the shooting game class, and then you would notice that I have taken advantage of the two lifecycle methods, the on pause and the on resume lifecycle methods, and then using that to either stop the background thread or to pause the background thread or to allow the background thread to resume. So in here, in the on pause method, whenever the on pause method of my shooting game activity is called, I'm going to stop the game, and then when the on resume method is going to be called, I am going to resume the game. So switching back now to the drawView.java class, let's have a look at the stop game and the resume game methods inside the drawView.java class. So switching back to the drawView.java class, down below here, you will notice me implementing the stop game and the resume game method. So in the stop game method, I will set the running Boolean variable to false because I want to stop the game. And then in the resume game method, I'm going to set the Boolean variable to true. So these two methods are implemented here. Getting back to the drawView class, that drawView thread class that we implemented here, you notice that we have the run method where we are going to insert the appropriate code in order to update the UI. In order to save time typing in the code, I have done the updates, and then I'm going to walk you through the code here so that you would understand exactly what is being done in this exercise. Now, getting back to the run method, you notice that I am declaring a variable called canvas, and inside here I have a while loop, and for this while loop I will execute this while loop only when the thread is running Boolean variable is set to true. So this is one way I'm going to stop updates to the canvas. So when the thread is running is true, then I'm going to execute the code. If that is set to false, then I'm not going to execute this code. So if this is true, then inside here I am going to use the surface holder to get hold of the canvas. So first and foremost, when I am updating the canvas, I should lock the canvas so that only this particular thread can update the canvas. And no other thread will be updating the canvas at the same time. Now, you can think of implementing multiple threads in the background which may be updating the canvas simultaneously. Now, in this exercise, we are using only one background thread, so this is not really essential. But in any case, if you were implementing using multiple threads, this is the first step that you should do before you update the canvas. So you lock the canvas and then go ahead and then update the canvas. So I am using the draw game board method that we had earlier to update the canvas. So the canvas is essentially the same that we have seen earlier. So we're going to update the canvas, and then you see that I have this statement called sleep 30. So this statement essentially tells this background thread to sleep for 30 milliseconds, and then after that it is going to post the updates to the user interface. Now, how do we do that? I'm going to come to that in a minute. So this is where we are going to do the updates to the canvas. Previously, we had similar code in the onDraw method of our view. Now this code is now shifted to the run method for the drawView thread here. So once you have updated this, then finally, after we are done with this part, then we are going to unlock the canvas and post. So when you call this method called unlock canvas and post with the canvas, this method essentially informs the Android framework saying that the canvas has been updated and it is time for the Android framework to redraw the user interface. You recall that when we used the onDraw method, we were calling the invalidate in order to force the Android framework to redraw the screen. Here we are going to do this approach. So you unlock the canvas and then post, and this triggers the Android framework to redraw the view on the user interface. So this completes the updates to the shooting game exercise. Now we can go ahead and then try and run this exercise code and see how it works on the screen. So once you deploy your application to the user interface, you're going to see this shooting game running on either your emulator on your rear device, and then the playing of the game proceeds exactly the same as before. So you can see that the game implementation hasn't changed a whole lot from the perspective of the end user, but inside we are now using the surface view instead of a view to update the user interface. In the next step, we're going to add some music and background sound to this game to make it a lot more fun to play in real life.